Hello, everyone. Welcome to the Neo4j Online Meetup. A couple things before we get started. For maximum visibility of the video, I suggest that you set your resolution to 720 megapixel. You can adjust it on the bottom right of this video. If you have any questions while you are watching live, you can ask them here in the live chat on the right-hand side of the video. If you have any questions afterwards, or you're watching this video not live after the live stream is over, you can actually ask the presenters any questions directly on the Neo4j community site. Very shortly, I'm going to have my colleague Mark post a link in the chat, so you will have a direct link to that. Also, if you've enjoyed the presentation, please give it a thumbs up on YouTube. And for next week's online meetup, we have the International Salmon Data Laboratory with Scott Ackenhead and friends. And if you are interested in presenting in the future for one of our Neo4j online meetups, you can post your project and or blog on the Neo4j community site under the content category or under projects category. So let's get started. I am Corrine Wallach. I am the community manager with developer relations at Neo4j, and I am here with my colleague, Mark Needham. Say hello, Mark.
Hello.
Mark is developer relations engineer also with Neo4j. And today we have with us two special guests, Jennifer Reif and Mark Heckler. Who is a Spring, well, actually, I'll let you guys do your own introduction. So how about that? And then we can get started.
Sounds good. So my name is Jennifer Reif. I work as developer relations on Neo4j. So I'm a developer relations engineer, do a lot of coding projects, speaking gigs, blogging, etc. So you'll probably find me somewhere on the web, Twitter, email, as well as some other places. So feel free to check some of that out and turn it over here.
Hi, I'm Mark Heckler. I'm a Spring developer advocate with Pivotal. You can probably find me when I'm not coding at my home office. The other 99% of the time, I'll be coding somewhere else or speaking somewhere. I live on airplanes and in hotels, and just love to code and talk. So that's why we're here today.
Yeah. All right, so let's dive into our project. I'm going to share this, and then I will flip over to this. Okay. Hopefully everybody can see that. Corrine, Mark, you're getting a good. Okay, great.
Yes, we can see it.
So just we wanted to kind of come together here and present kind of this conglomeration project, kind of a meeting point of Spring as well as Neo4j. So a little bit of background on this. We kind of wanted to combine the power of Spring and what it has to offer with graph databases, with the graph data structure that Neo4j offers. Wanted to walk through some processes, how you kind of get spun up, looking at a real world use case, how you get that into Neo4j. What are the processes like for Neo4j for importing data, for querying that data within the database, and then analyzing it, making decisions on it, or getting value out of it. And then we wanted to bring in Spring Boot, Spring Data as much as we could, and kind of show that connection. Spring Data has a lot of really nice connections with various databases, and Spring Data Neo4j is one of those projects that offers connection with Neo4j. So we wanted to bring that in, and then of course create some nice UI, some pretty web page that's kind of fun, but that also allows you to visualize and to see the data that's actually coming out of that database. And to do that, we're incorporating both time leaf templates as well as D3 visualization that connects with Neo4j very nicely. So, and what kind of data could possibly go well with Spring and Neo4j that would be a lot of fun, but also be very applicable real world? why not Marvel Comics? So that's what we decided. Marvel has a really nice, actually, online API through developer.marvel.com, and I'll actually spin over and show this to you guys. But you can set up your own account. They'll give you an API key. They have some really nice interactive documentation that kind of gives you kind of the objects and the data that they have available for you to query. And then you just basically can create your own data model, however you want to lay that out in Neo4j, create the cipher statements, and import that.
And I will throw in, and Jennifer had to do all, and I mean all, of the heavy lifting with regard to bringing the data in on this. But I will say that Marvel has created an API, but they have largely abandoned the data set. The data set is not, they did a dump. You can tell they put it all out there, and then they walked away quickly. So you have varying degrees of quality in the data set, which, again, we felt like, as frustrating as it was to deal with and to try to work through, very accurately mirrors any real world scenarios in pretty much any industry that you might be in. So it served as just a really ideal example case, as well as just kind of making it a little more fun to see the outcome.
Yeah. Okay, so let me get out of presentation mode here. Whoa, that's odd.
Okay. Inception.
That was really odd. Okay, so this is the website. It's just developer.marvel.com. You can sign in, create an account. They'll kind of give you some information on how to get started, what you can kind of expect. So it tells you to get an API key, just be a good citizen, keep in touch, etc. They like, of course, to see the projects that are going through. I think one of the questions when you sign up for their for one of their accounts is they ask you, what do you plan to do with the information, basically.
Which, if I could interject here as well, we're not really sure why they asked that, because they never really engage. So I'm not sure they really care. We even had, as Jennifer will get into, the rate limiting is extremely restrictive. So you have to do some really creative things to work around that, which she will get into in a bit. But I even inquired about a paid subscription or some paid tier, and not only didn't get a satisfactory answer, didn't even get an answer, didn't even get an acknowledgement. So literally, it was a data dump. We appreciate them putting the API out there. We appreciate them exposing the data. But as with many things, again, in the real world that you might need to do for your job, there's a certain lack of sufficient level of support there. So.
Yeah, you're kind of on your own once you get the data,
right.
Which, you know, the results may vary on what you want. But so I'll skip down over here. We'll talk a little bit more about kind of the limits and such, and how we ended up having to kind of go around some things to get what we needed. But different APIs will have different restrictions, and so it's just good to know what you're getting into. And that was one of the things we evaluated this site on. Was, can we get what we need out of it? Is it going to be enough to put together a project on it and do something really interesting with the data? What I liked most about this is there's interactive documentation, which is actually pretty good. You can just open up and it gives you the URL that it's going to hit, gives you all the information about what you can expect to come back for a character. And so you can set different, parameters and such, set all this information, and then actually test the call out. It does tell you it will only return 100 results at a time. That was one other thing we kind of struggled with a little bit when we wanted more than that. But this is a good place to get started, especially when I started digging into running Cypher queries and such against the API. And trying to import it, I didn't always know what I was going to get. So it was good for me to come out here to the interactive documentation, to actually test the call and look at what do I get back, what do I see, and then try to mimic that in the Neo4j browser to pull that into Neo4j. So this is a good place to get started. It does count against your daily rate limit. So just so you know, you're only allowed so many calls. So don't use them all up here. But it's definitely a good spot to kind of figure out what you can expect and what you're going to get out of it. And the keys, you can pretty much just set these up. They just ask a little bit of basic information, not too terribly difficult. They weren't overly invasive or anything like that on it. So really not too terrible on that front. Okay, so that's that. So now that we kind of figured out our data, we got our documentation, we know what to expect coming out of the API. Now we can kind of create the data model that we want Neo4j. What do we want this data to look like when it gets to Neo4j? So I took my whiteboard out. Neo4j is known for being whiteboard friendly, so why not use it? So I pulled out my whiteboard and started to draw something up. They have basically 6 main areas, 6 main kind of object classes that they group their data into. I'm sure on their back end it's in tables in a relational store. That's my assumption. I don't know that. So I just kind of grouped into 6 different entities here, and then tried to figure out, okay, what do I want to be the center of my data model, of my graph? And I could have gone from a character's perspective, gone and looked at if I was really invested and felt that characters were the most important to my use case, I could have made character the center of my model, and then figured out how characters related to everything else. But what I ended up deciding is this data set, the API, is all about Marvel Comics, and it's based on the comic universe. Of course, there's been movies and other things about it, but all at its core, it comes back to that comic issue. So that's why I ended up creating as the central node in my database, and then determined, okay, how does the comic issue relate to all these other entities? So it belongs to a series. It's created by a creator. It's part of an event. So events would be major kind of changing story events throughout the comic series that might occur. And so I said that a comic issue could be part of an event. Comic issues are made up of stories. I think they explain this better on their documentation, but you have a cover story and then you have the actual interior readable story in the center. So typically comic issues are made up of 2 different stories. And then comic issues include characters. And of course, based on the different comic issues, you could have different characters or multiple characters included in that comic issue. So that was kind of the center. I drew that up first. And then when I actually imported the data into Neo4j, that's what shows up on the right hand of the screen here. That's the data model in Neo4j. So again, it looks exactly the same as how I drew it out. I just had to import that data from the API and make it fit this model now. So I've already mentioned a few different rules and restrictions that an API could put on you. It's not just Marvel, it's a lot of different APIs that are out there and offered. Each of them is going to have a different level of supportability, as well as just some different restrictions they might put on you. Call limits, API keys, result limits, infrastructure, and support. We've mentioned a couple of those. For this particular API, it was really just trying to get as much information as possible, because there's thousands upon thousands of comics, and probably thousands of characters and tons of series and stories and all this. So it's just a massive amount of data. But you can only return 100 results at a time. And I didn't find a way that you could page through those results. So they would only give you 100. And you had to stay under a 3,000 call limit. So you can only make 3,000 calls to the API in a 24-hour period before they cut you off. And they really did cut you off. I tried it a few times and they're like, nope, you're out. You're done for the day. So then I had to wait until the next day to continue. So it was all about just trying to get as much information as we could packed into those limits. We were able to do it. So when we started importing sections, I had to write up some Cypher queries to do this. And I used a few different libraries to help me along the way. But good, just kind of database maintenance. You want to set up good indexes and constraints so you ensure your data is unique and clean. I also set up some parameters so that I wouldn't have to type the API key consistently for every call, or wouldn't have to try to screen it out if I sent the Cypher query to somebody else to look at. And then we had to find the smallest entry point. This took some trial and error, but we talked about this quite a bit. What's kind of the smallest point that we could get the fewest number of calls and get quite a bit of data? What we started with was starting from the characters and just going through alphabetically, because we figured there probably aren't too many characters starting with the letter A. There probably aren't too many characters starting with the letter, S or T. We might be able to make this work within 100 characters. And we did. I think there were only 2 or 3 letters that ended up being over 100 characters in a call. So we only missed a couple, just a little bit. So we were able to get the bulk of what we needed within that. And then based on the characters we imported, we could start importing the other things. So I think, yeah, let me show a little bit of that query, the queries that I ran. Oh, where did it go? Hiding. There we go. Okay. So this is the cipher that I ran. These are, I set up my parameters. No, you don't get my API keys. Sorry. I screened them out. And then I just set up some constraints here for my IDs on each of my nodes here, and then set up a few fields that I knew I was going to call and search for quite a bit in my queries. I just set those up as indexes so that I would be able to use them. The first thing I did is I'm going to load characters by name, starting with each letter of the alphabet. So I'm using a lot of APOC procedures throughout this. They were really, really helpful and really saved my skin on kind of reducing those call limits and such that I was talking about. So just set up a timestamp, pass my API key in, and then this periodic iterate, all it basically does is it takes the first cipher statement that I feed it, and for each result that comes back in that, it's going to run the second statement. So basically what I did is I just unwound each letter of the alphabet. And for each letter of the alphabet, I'm going to call the Marvel API and say, give me everything that starts with the letter A. Okay, once it retrieves that, it's going to create those. That's what this merge does, create those in the database. And then I go back and it iterates again. Okay, give me all the characters for the letter B, and does the same thing over and over. And so I import all my characters. This is just some stuff to kind of see how the query ran. Was it successful? How long did it take? How many operations did it fail at, etc. So just some good statistic information on that. Then once we get those characters in, then I want to try to reach out. And for each one of those characters, I need to try to reach out and grab the rest of the data. So for comic issues, series, stories, events, and creators. So basically what I did is I looked at what data do I have in my database now, all of my character nodes. For each one of those nodes, which is match character, and see where it doesn't have any relationships yet because we haven't created that. It's going to reach back out to the API here, apoc.load.json, and it's going to retrieve comic issues. So it unwinds all those results, creates comic issues as well as the relationship here. And then it does that for each one of the other nodes. All this code is out in the repo. We'll send a link out at the end. You guys can review this on your own. What was different is we threw this apoc.util.sleep in the middle. As he talked about just a few minutes ago, their supportability sometimes wasn't all that grand. They did have some servers just randomly drop out when you're in the middle of a call, which is quite frustrating when you have a call that runs maybe 2 to 3 minutes to retrieve and insert all of that data, and then to just randomly have your server just bottom out from under you. So what we ended up doing is basically putting the sleep command in the middle to let it sleep for 2 seconds before it tries to reach back out to the API, so that maybe it would hit a different server and kind of keep this process going of not holding up a server for too terribly long. That was something one of my colleagues helped me with, trying to figure out, no, it's not any poorly written cipher on your fault. It's actually their servers that are falling on you. So that fixed that. And again, just kind of some statistics on how the query ran. That was really important, especially on this massive query here. That was really the bulk of our data import right there. Then once we imported kind of these smaller, so especially for series and events, basically what I'm doing in this query is I'm just inserting the node with just a couple of basic properties.
Jennifer, would you be able to zoom in a little bit on your screen? I'm not sure if you can or not. It's just kind of hard to read your screen, I think, some people.
Oh, I won't zoom anymore.
I'll go to presentation mode if you want.
Okay, how do I?
Do view.
View, and then.
Or just, read it off line by line, letter by letter.
Is that? Oh, that's much better.
Yes.
That's very large.
That's nice. Thank you.
No problem. So what I did the the massive bulk query is I just basically wanted to insert the node and get just a basic couple of properties in on each one of those. Then I might want to go back and import a little bit more data, get a few more details about the nodes. So for series and events, that's what I've done here. I basically looked at all of the series that existed and see, hey, is there a particular property that I wanted that doesn't currently exist on that node? If so, then that's when I'm going to go back out to the Marvel API and I'm going to populate that information. So I populate start year, end year, rating, etc. on those. And same thing I did for the events. There was a start and an end on the event. And I wanted to populate that as well for some of our queries. So then I just reached back out, said, what events do I have currently in my database? Go back out to the API and just basically hydrate that with a little bit more data. And again, the statistics at the end. So that's pretty much.
Not sure why that's not working.
Yeah, that's odd. Import.
Go all the way.
There we go.
Yeah.
Okay.
And you do. Yeah, that's bizarre.
Yeah. Okay. I'll have to play with that.
Yeah.
Okay. So if we go back over to Keynote, we'll switch and talk a little bit about now Spring and the application side of things.
Yeah. Hi, I'm Mark again. So we wanted to kind of get up and running fast and to be able to do things, move fast and get things done quickly in a very efficient way. And Spring gives you a lot of capabilities to do that. So Spring Data, one of the Spring Data projects is Spring Data Neo4j. There are others. If you have to use a different kind of database, you certainly are supported in those areas. So various different NoSQL databases as well as relational, anything with JPA. But obviously the crown jewel in this case, in many other cases, is Spring Data Neo4j. But what Spring Data provides is a couple of tiers of support. One is basic template support, which is kind of a very basic level of interactions with various database engines. And then at a much higher level is the repository support, which gives you this kind of built-in capability to get counts, record counts, for instance, or document or object counts. And then as well as things like find all, find one, delete all. So some very general operations that you would apply pretty much for any database that you would have, any database need. So as a developer, it makes it very consistent, very easy, very low friction to switch. Because in most cases in our world, we just have to deal with a lot of different backing data stores and different interfaces and what have you. So the more consistent we can make that, the more productive we can be as developers. So Spring Data provides that. Should I go on into the Spring Boot part yet?
You can a little bit, yeah.
Okay. Spring Boot, for those who may not know, Spring Boot actually ramps up that productivity even more because it gives you access to the plethora of Spring components, as well as many other things in addition to that. But you start with the Spring Initializer, which we'll kind of get into in a bit as well. But that kind of cuts through in a very opinionated way to get you up and running with a project skeleton very quickly. It allows you to make a few very simple choices, and you're off and running with a project scaffolding, the structure. Spring Boot basically delivers three things for you. One is it simplifies your dependency management. Spring Boot application, rather than have pages and pages of dependencies that you might need to provide a typical bit of functionality throughout your applications, it creates nested nested POMs. So you have a bill of materials type of structure. Because let's face it, when we need to provide a basic bit of functionality, that usually involves several different dependencies to do that. That work together, and Spring Boot allows you to simplify that, or enables you, provides that simplification for you in terms of dependency management. It also gives you auto configuration. Sometimes you hear folks refer to this as magic. The great news is it feels magical. The bad news is it's really not magic. It's science and technology. But the idea is that if you have Spring, I guess let me back up just a bit. Spring Boot, when you do a build, when you do a run, it actually evaluates your code, your annotations, and your class path to determine what kind of support that you would want to be provided for you. So for instance, if you extend an interface defined in Spring Data to interact with the data store, and you have a database driver on your class path, so for instance, if you extend a Neo4j interface, Neo4j repository interface that's defined in Spring Data, and you have a Neo4j driver on your class path, Spring Boot somehow magically determines that you want to interact with the Neo4j database. So it's not rocket science. It's just a very methodical and logical set of analyses that occur to provide you that capability without having to write a bunch of code and scaffolding code in your own code, and allow you to focus on the real business value-adding code. The third thing, of course, is the Uber jar, the ability to deploy anywhere there's a JVM. So whether it's a laptop, server, cloud platform, it really doesn't matter. It just makes the deployment as simple as the dependency management. So that's kind of nice. And other things it says here, of course, which I kind of hit on the top several, but the annotation-based object graph mapper for POJOs, for plain old Java objects, and Kotlin objects for that matter, and Groovy. And of course, you can connect to Neo4j in many ways. So it gives you a lot of flexibility. It allows you to not have to work and specify every last bit of configuration and scaffolding around your business value-adding code, but you still have the ability to grab and move any of those levers and turn any of those knobs and punch any of those buttons you want, should you need to. So right. That's kind of powerful.
Yeah, and we weren't. I mean, you can substitute Spring Boot out. You don't have to use Spring Boot.
Sure.
You could substitute out Spring Data Neo4j and use just a regular Java application connecting to a Neo4j driver. We have a lot of different language supports there. We just really felt that the value added for Spring Boot and Spring Data Neo4j was that it got you up and running quickly and provided a lot of things out of the box for you that maybe you didn't have to worry about configuring all this stuff in advance before actually getting the application to work.
Right. As with all things, the goal is real working software quickly and reliably, and that's what we went for. So
switch to Spring Initializer. Look at Spring Initializer.
Oh, sure. Yeah, let's do that.
I have to skip the presentation first.
Oops. Okay, so
next tab over.
So this is the Spring Initializer. As I mentioned, it's kind of an opinionated approach. And as with all things Spring, there are certain opinions that are specified and that are embraced throughout to streamline your development. That's not to say you don't have options. In the old days of framework development, you typically had one way of doing things, and that was the framework way. And if you tried to fight the framework, you lost, typically. But with opinions, what that does is allow you to, in that 80 to 90% of all use cases, to simply go forward in a very quick and direct path. And if your use case falls in that other 10 to 20%, you still have the option to go back and specify the other things that you need to take full advantage of that without fighting the framework. So it actually supports you in pretty much every way. So this is the most opinionated way into a Spring Boot application. So if we switch to the full version, that allows me to show you some different options that are already chosen for you if you don't necessarily specify. You do have the option to choose jar packaging or WAR if you still have to deploy to an application server. Certainly not optimal. The reason I say that is because of the 12 factors. If you're not familiar with 12-factor applications, the 12-factor manifesto and its variations, that's a good thing to read up on because it gives you a good start in terms of how to be a good cloud-native citizen with your application, how to best be scalable and resilient, and all the other things that we need and want to be in the current environment. We have to be very nimble and responsive, and this gives you a better way to do that. But if you have to, you can deploy to a WAR as well. It's still fully supported. The Java version defaults to 8 on up. Everything is supported all the way through the current, as well as the early access of even 12. But certainly 8 on up is right back in there from the start. And then any of these options that you see, you can choose from, and that does another thing. That's another part of the Spring Boot value, which is it version synchronizes. So whatever version of Spring Boot you've chosen, in this case, the current version is shown, plus a couple snapshots on either side, and one previous version, and then of course the previous major release of 1.5, which doesn't include some of the extra features, obviously, of the 2.0 release train. But whatever version you select, whenever you select, for instance, reactive web or security or cache or Groovy templating. It synchronizes, version synchronizes with that version of boot. And what this allows you to do is to get out of the games of dependency whack-a-mole. If you're not familiar with dependency whack-a-mole, you will be eventually, probably, as a developer. But it's the idea that among our many dependencies, at some point, typically when we upgrade dependencies, things sometimes break. And we see nothing out there that gives us an indication. We don't get a good stack trace, anything that tells us exactly what's going on. And finally, after multiple days of frustration and searching and testing and trial and error, we find that if we just roll back version library B to version 3 instead of version 5, everything magically works. So with the version synchronization, based on whatever you select here, then that keeps you from doing that, because these various different libraries and the versions that are synchronized with the particular version of boot you choose, they're version synchronized, they're battle tested, they're proven. So you don't have to specify those versions, which again streamlines your life as a developer. Now, of course, you can overwrite that if you have a particular version of a library that's shown here. For instance, my baddest, then you can certainly do that. Or if you want to bring in your own dependency, of course, you can do that as well. But for the vast majority of cases, it's all handled for you, which streamlines and makes your life that much better and lets you, again, concentrate on the stuff you want to and need to concentrate on. The good news is, if we switch back to the simple version, we don't have to mess with any of that. We can start specifying just by typing. So if we want to bring in web and bring in Spring MVC, we can do that very quickly and easily, selecting that. If we want to bring in Neo4j, of course, then we can do that. And it's a very simple search selection. You can choose to use generate a Maven project, which this doesn't generate code other than your main application class and your main method. But it does generate your project structure, as I mentioned, the scaffolding, the skeleton of your project. So if you're a Maven developer, you can generate a Maven project. Or if you're a hipster, you can generate a Gradle project. It's all good. Some days I'm feeling pretty hipster, some days I'm not. So we support both right out of the box. Java, Kotlin, and Groovy support. And of course, as I mentioned, various different versions of boot. Once you generate the project, you typically open it up, and you're off and running with your code. So I think that's pretty much it.
Yeah.
Let's just switch back to the IDE, and we'll take it from there. So
yeah, perfect. Okay. So we kind of created folders to kind of keep everything a little bit neater. We have a lot of classes, but really it's not near as intimidating as what it looks. So we started when we started coding. Again, we looked at what's the simple entry point, what's really easy to build, what gives us some results, and what kind of is the easy on-ramp to building an application. So character was that for us, because most people, even if you're not a Marvel Comics fan or a Marvel movie fan, most people are probably familiar with a lot of the Marvel superheroes, just in kind of pop media and such. So you start with some characters. It's an easy on-ramp. I know I'm going to have a Neo ID. What this is Neo4j assigns an internal ID that it uses just internally. It's very rarely, hardly ever used for like user interfacing, but it still has to be there. It just gets assigned internally. So that's going to be our main ID. We're going to give it that @ID and @generated value annotation for Spring. And then just let it roll with that. And then this other ID we created.
Jennifer, sorry to interrupt. Can you enlarge your display by chance?
Sure.
Yep.
And this apparently doesn't work. So yeah.
Yeah. Okay. So view.
Bizarre.
Go back to presentation. Okay. Much better. All right. And then the second ID is basically the API ID. So what we wanted to do is we wanted to kind of keep that API ID in case we would need to reach out to the API, in case we would need to synchronize it with the Marvel API side. So we wanted to be able to reference that and use that as well.
And because, of course, everything is associated on that from the data dump. So
correct. Yeah. So all of your resource URI, even the thumbnails, probably some of the other items probably have that ID embedded in them.
And if I could interject here, what you see in terms of the annotations at the top above the class header is basically a couple of different things tied in. One is @data, @noExConstructor, @requiredExConstructor. Those are Lombok annotations. Lombok is a compile time generation library, so it gives you a way to reduce your boilerplate in your Java code. We've had a kind of a love-hate relationship with Lombok over the years. It's very good about some things. It has its own quirks and not so great about other things, but in general, it's a very useful way to cut down the amount of boilerplate code, especially on domain classes that you'll typically have. So @data gives us our getters and setters, our equals, hash code, and toString methods by default that we don't have to code. And by the way, sometimes folks say, well, why? I mean, my IDE generates those. Why should I care? That's great for the generation, but of course, every time you need to change something or evaluate something, you still have to page through the mountains of code, typically with a complex domain class. So this allows you to not have to do that at all. The code you don't write is always consistent code. Again, with Lombok, sometimes that's not necessarily a good thing, but generally speaking, it is. And then we get into the @node entity. Oh, I should specify that @noargs constructor is so that to provide a no arguments constructor for JSON marshalling and unmarshalling. And a required args constructor simply creates a constructor with parameters for any of the non-null member variables that we've specified. So for instance, the ID, the name, description, resource, URI, and thumbnail, there will be a constructor created with those arguments, with those parameters by Lombok for us. The @node entity, of course, is Spring Data Neo4j annotation, which indicates that the character entity that we've created here will be stored as a node in Neo4j.
Well, that just lets it know that it's an object. And then, look at you.
Tag teaming here on the keyboard. So.
Yeah, we have to share a keyboard. That's difficult for both of us.
Right. It's pairing, real life pairing on a meetup.
Pair programming. So we're going to create our repository interface then. And this is just, again, a very basic framework. Really, we're going to pack most of our repository information and details and methods and such into our comic issue, because that's going to be our central node in our database. If you remember, our data model, excuse me, if you remember from the data model I showed earlier, of course, we could add character methods to this. So that way, if you call the character endpoint, you could retrieve stuff about just the characters and information related to them. However, at this point, we don't have that information here. We wanted to start kind of with that comic issue. And then, of course, we could build out and make this app, a lot bigger.
And then just to interject here, this is kind of what I was referring to earlier about the repository support in Spring Data / Spring Boot, because we're actually just extending a repository interface that's defined in Spring Data called Neo4j repository. And we're saying that we want to interact and persist objects of type character with our character, which gets us to another thing that we'll discuss at some point later on, but a Marvel character with an ID of type long. And simply by extending an interface in Spring Data and having Neo4j database driver on our class path, Spring Boot creates the configuration beans, if you will, to support that use case for us. So this is all we have to specify, and it gives us certain basic capabilities. Again, that getting a count and doing a find all and find one, delete all, delete one. If we want to add additional methods, as Jennifer mentioned, we can simply define those here by a convention that's well specified with Spring Expression Language, using various different query languages, including Cypher.
Mm-hmm.
But of course, in this pretty basic example for character repo, we didn't have to do any of that. I think we do later in comic issues.
Yes.
But certainly you have a lot of flexibility, a lot of power here in a very simple single line declaration.
Yep. Should we jump to the controller?
Sure.
Okay. So finally, we come to our controller, and this is kind of the go-between between kind of the requests and the database. So it kind of manages the request coming in. It says, what do I need to bring back from the database, etc. So it kind of handles that intermediary. So all we're going to do here is we're going to say this is a REST controller. So we're going to give that @REST controller annotation on it, which basically loops in the @controller as well as the @response body annotations. So it takes care of all of that. I'm still relatively new, so he makes sure I'm giving you guys the correct information on all these annotations.
Yeah, and just to interject that, with Spring, you can define an @ controller, which involves a templating engine. I'm not sure if we get into this more later or not. I'll give you a very quick overview now, but that will involve a templating engine so that if you return a string, it will evaluate that string, say, we will get into that more later,
Yeah.
but it will load up an HTML file which can have various different template markers in there for rendering the way you want it to be rendered. But if you want to pass back straight JSON, for instance, or XML, or what have you, and in this case JSON by default, you can pass that back. You indicate that as a REST controller, and then it will pass back the response body, the method return value in the response body, I should say. I'm kind of getting turned around here. But basically what that means is you can directly pass back JSON to your browser. So this is what we wanted to define here, is just an API. We didn't want to define a front end for our characters. We just wanted a way to retrieve them.
Yeah. And then we have our @request mapping, which says what endpoint we want this API to be accessible via. So we have our /characters. So you could potentially hit the /characters URL, and it would return back JSON of what you can pull back. So in this instance, we're just going to connect our repo that we set up, the interface character repo. And then we have our @get mapping that says this is going to be a new mapping endpoint. We're going to
straight off of characters. In this case, we're adding nothing to it, so it'll just default to whatever your base URL is plus /characters.
Right. And then we're going to set up the method of get all characters. So, and then we just do a repo.findAll. So that's going to return everything that it can find for character in the repository, and just return all of them back. So that's what gives us this iterable of type character. So it's going to come back with a list of characters, basically, a general list. So, and that's pretty much all we need to define here, because when we hit this, we just need to return all the characters. Again, we could get fancy, we could add more methods and such, but at this point for this application, we didn't really feel that necessary for right now.
So you want to cover comic issues?
Sure. Just to let you know, too, the creator, the event, all of our other kind of extraneous, not extraneous, I shouldn't say that, but just kind of external nodes that we had that we loaded in, they pretty much followed the same thing as character. It's just a very basic skeleton outline. We just defined a few fields in our object classes, our entity classes. And then we created a repository, again, with no methods or anything extra defined there, just as we did our character repo. And then our controller sets up a few basic methods to do like find all, and just retrieve basic information about those. Where it really starts to get interesting is when we start looking at comic issue, because this is our central node to our data model. And so this is where it becomes the connector to all the other pieces that we set up. So all of our other 5 classes, our character, creator, event, series, and story, those just had kind of the basic information. Now we need to tie those all together using the comic issue classes. So to do that, again, there's a lot of things that are going to be similar here. So the @data, the @noArgs constructor, @required args constructor, and the @node entity, all are the exact same as what we saw in character, and the other 5 kind of entity classes as well. All of that kind of sets up that information for you. We're going to define our variables here. So our Neo ID, again, that internal Neo4j ID, the ID coming off of the Marvel API, then a few string variables, and an integer variable and a double variable. So very confusing, but that's all on the Marvel API documentation, again, what these numbers are returning. And of course, we try to keep those values as much as possible. Then where it gets interesting is where we start defining these relationships. So this is where we're taking our nodes in our database, and we're saying there's going to be a relationship between comic issue and, in this first case, character. There's going to be a relationship between comic issue and creator, and on down the list here. So we use the @relationship annotation to say we're creating this relationship that exists in the database, but we're creating this in our application, that these 2 nodes have a connection. And we're going to say this is a type of includes. So remember, again, from our data model, we inserted that relationship as being a relationship type of includes in the database. So we want to mirror that here. So a comic issue includes characters. and it's going to create a new array list that will bring back a list of type characters. While I'm at it, I will go ahead and explain the character confusion. So we didn't really think about this until we actually got into coding some of the classes that are coming up.
This is what comes from being very, very focused on your data import and not so much on the coding part initially.
Right. Yeah, maybe we should have kind of rethought some things, thought ahead a little bit. But some of you may have already made this kind of connection, but there's a Java type of character as well. So with us writing this code in Java, when we would type character, sometimes it would say, oh, you mean the java.lang, character, whatever it is, rather than our particular entity character.
Yeah, so not anything, not the end of the world, certainly, but certainly something you want to be aware of.
Yeah.
And maybe a little more focused on better naming.
Right. we probably should have gone with like comic character or something like that. But yeah, that caused some confusion because we would accidentally import the wrong thing. Oh yeah, this needs an import, just import that, and it would import the Java character type rather than our particular entity type. So that caused a few little red squiggly lines where we have to go back. What is going wrong? Oh, wrong import. So yeah, just be mindful of naming on those sorts of things. So kind of interesting, but very funny now. And then, of course, we do the same thing across for our creators. We create the relationship type that we have in our database, and then create an array list that will come back with a list of that particular object type. So this is where you basically just set up that connection, saying this comic issue entity has relationships with all these other entities. Okay. You want to talk about the first two, and then I'll wrap up the last one?
Oh, sure. So, I mean, we see basically the same pattern as before with our character, in that we extend an interface defined in Spring Data, the Neo4j repository interface. This time, though, we're going to create a repository that will persist objects of type comic issue with, again, an ID of type long. And then you see the general convention with the first couple of methods defined here. We're going to have a find by name and find by name like method that we want Spring Data to implement for us. And this is a convention, right? So you have a find and by, and then of course Spring Data will offer you up different fields, different member variables that you can use. So if I create, for instance, let's see, comic issue find all by, find comic issue by, find distinct by, find first by, top by, what have you. So it allows you and it helps you to structure a very conventional query that you don't then have to specify anything behind, but Spring Data will understand and interpret that for you and provide that implementation for you. That works exceedingly well for a vast majority of use cases. But if you have a very specific use case that obviously Spring Data can't foresee all, but if you have a particular use case that you want to specify very specifically, then you have that power at your disposal as well with the @query annotation. And you can use that to provide, in this case, Cypher queries, full-on Cypher queries to provide any kind of capabilities you want, or ask Spring Data to provide that capability based on the query you provide.
Right. So if you're used to writing Cypher, this just allows you to kind of write queries just as you are normally used to, which is really helpful for me. I've written SQL queries. I can figure out other things as well, but returning Neo4j entities and relationships, writing Cypher is just kind of native for that. So I can write something that's very native and get the results I'm looking for. So in this instance, I use the @query annotation. And then all we're going to do is we're going to look for comic issues. So that's match comic issue that has a relationship with any other node type, and return each of those. So we're going to return the comic issue, the relationship, and the other node. And then we might set an arbitrary limit. What this is going to allow us to do is, if you have thousands or millions of nodes in your database, this is what's going to power our visualization. So we don't necessarily want to overload our web page or our visualization with hundreds or millions of nodes. And so we could set an arbitrary limit. Hey, maybe this time only bring back 5 nodes. My internet connection is super slow. Or maybe this time only bring back 100 nodes. And so we can set that. And then we'll set up our method that goes with that query called graph. It's going to return a collection of comic issues. And then we, again, can pass in that parameter of limit. It's going to be an integer value. Okay. So now comes our service. So this is a little bit of a different structure than what we did with our other entity classes. So last time we had, just our character repo, and our character controller. What we've done here is kind of section out a little bit of that kind of logic and code and kind of break those into two parts. So we have some things in our controller, and then we try to go through a lot of the logic and bulk of code in our service layer. And
if I can interject here, this is kind of a matter of preference, right? So if we look at our controller, we know that we want to expose this capability externally. So we know that the Spring Data repository gives us quite a bit of capabilities right out of the box. And that's great for, again, those various things that you can either depend on out of the box or that you can write even a very complex Cypher query for. But if you need to do something like format it, in our case, we wanted to be able to make a really, really cool formatting to where we show the interactions and the relationships visually via a web app. And if you want to do some very complex things like that, obviously the repo is not the right place to try to jam that functionality and capability. So what we wanted to do, or what we wound up doing, is creating an internal API, an internal service layer. Certainly not required for simpler use cases, may not even necessarily be the way that you prefer to go, even for more complex ones, but we felt it made a much more clear line of delineation between your repository and your external API, which we're building here with the comic issue controller. So you see, should we go ahead on this now and then backtrack to the internal? Yeah. I think that might be good too. So we see here some very basic information. The all-args constructor just allows us to, with Spring, we're going to auto-wire or inject our comic issue service so we can access that internal API. With Lombok, you can ask Lombok to provide an all-args constructor, which again, will look at your member variables and say, hey, that's for an argument, we'll provide a constructor with that particular parameter in it. So it will then auto-inject, auto-wire in that issue service to access it for our backing API, which is pretty nice. The at controller, again, just says, hey, I'm going to use a templating engine unless I specify, for instance, on these other methods, some of these, that I want to provide a response body and return that directly as JSON in our document. But for at controller, it just means that unless provided with a response body annotation, expect a templating engine to kick in and return an actual page. We're getting everything off of the /comic issues endpoint, and then we're going from there to build out our API for our comic issues. So starting with our find by name, and then find by name like, these are simple pass-throughs, right? They're going to call our issue service find by name and find by name like, which in turn will call our repository find by name and find by name like. This is a bit of the repetition that you kind of fall into when you create that internal service layer, but it allows everything to consistently access layer to layer versus kind of this hodgepodge of hitting the repo in some places and hitting the service, the internal API in other places. We felt like, again, for consistency and clarity, that it made sense to do that. Here we have another API exposure, which provides that response body. It returns JSON in the terms of a map of string and object keys and values.
And that's what's going to pull our the at query annotation with that Cypher query. This is the endpoint that's going to pull that JSON back from that query and return our graph. After it goes through some things. Via
our issue service, exactly.
Yeah.
But here's the endpoint that we're actually going to expose that will return our web app. Yeah. So that will return issues graph, which if we understand this correctly, since we don't have a response body, our templating engine, in this case Timeleaf, but certainly others are possible, FreeMarker, Mustache, what have you, will return that HTML page with our templating tags, and then off we go. But just to go into the graph, which will take us right back to our service layer.
So there's a lot of code in this one, and yet another reason why we wanted to kind of section out the controller versus the service, just to kind of, it would get really kind of blinding to sift through all the code if we put it all in one class. So this is, we're going to give, again, that at all args constructor, excuse me, and then at service to say this is a service class. And we're going to connect our repo. And then I'll kind of skip down to the bottom, and then I'll zoom back up. So we're going to set up our, that's not plugged in yet. We have our find by name and our find by name like methods down here that we've already talked about. And the transactional, I believe what that does is it, I think it just reads. I'm trying to remember exactly how that handles that.
I'm doing the same thing. Let's just go there and take a look at it. Yeah, so we've got a transaction manager brought in, and that's specific to Spring Data Neo4j, I believe.
Yes, it is.
So that's just something that we need to add in order for consistent results, presumably. Yeah. So let's go back here.
Oh, there's something between read and write. I think it handles read only at that point. Yeah, read only is true. So it basically allows people hitting this service not to be able to write for these methods. So it handles it just slightly differently. I'd have to go into the documentation to recall exactly what all the finer points are on that, but it just kind of handles that very uniquely there. So we have our find by name and our find by name like methods all set up. And then what we're going to do is this graph method that we've already shown in our controller and repo classes. Now, what that ends up doing, we have a...
If you notice, we're wrapping our issue repo call, which we're providing the limit that we're receiving when we call this particular method, but we're calling our repo graph method with that limit, and then we're wrapping it, or well, effectively, we're using that as our parameter to D3 format method, which gives us the format we need to provide back for D3 in our browser, in our web page.
Yes. So we'll call our repo and call that graph method, pass in the limit, and then around that, once we get kind of those results back, then we're going to format it the way we need to. So D3, what it requires is it requires a particular map layout in order to basically map your nodes and your relationships. So that's what this is going to do. It's going to return a map of string object. We're calling this method to D3 format, passing in an iterable of comic issues, and then we're just going to basically loop through what will come out at the end of this. So we'll loop through our characters, we're going to loop through our creators and format them, series, stories, and events. And then what we'll get out of this is we'll have our nodes map, and we'll have our relationships map. And so, of course, you can see, again, we've wrapped, again, our return value. We're going to call yet another method that we're going to pass in, and this just basically formats that map for us.
And certainly you can put all this in your controller class definition, but as you might imagine, as you can see, it's a little much. So we felt like building, in addition, the other nice thing about building your internal API and keeping that distinct from your external is that it increases and improves your testability, which we won't really have time to go into here, but certainly that's a very, very important concern when you're developing code that you want to make sure works.
Yeah. Yeah, so we felt that this just kind of made it a little bit cleaner, as well as easier to kind of tack on some other things, test and things like that.
Nice separation of concerns, yeah.
Yeah, so then jump over to the HTML page.
Sure, if you want to.
The .html, issues graph.html.
Yeah.
Okay, so this is just HTML. It's going to format our web page for us, and then we'll jump over and actually show you guys what it looks like. But we'll just set up, this is for our visualization. It's to, some pretty colors here on some of our nodes, which we'll show that here in just a bit.
You have to make it pop, right?
Right. And Neo4j is really pretty when you throw it into visualization. Yeah. So we just have some basic outlining, some headers and things like that. And then we'll define, this is where it pulls back, our characters and our creators that we have from some of our methods. These are all the iterables that we can actually loop through and show.
And And here's where it gets good.
Yeah, here's where it gets really interesting. So you can see our comic issues find by name. It's going to look for a particular comic. It's going to format all of that and put it into this nice, pretty HTML look. And of course, format all the other objects in there as well. And then each time we have a list of comics that show up on the left-hand side, and each time you click, it'll render the graph again for you. Which is kind of nice. There's still some things I think we can plug in to make it even nicer, but we've gotten that far. And you can run searches. So we have a search bar at the top. You can search for a particular comic. So you could search for everything that's Iron Man, or you could search for everything that's Hulk or Black Panther, or what have you. And so this is where it goes into that comic issues find by name like, and you can pass in a string that you're searching for, and it will return everything that it finds. Similar to that.
Let's show.
Yeah.
I mean, this is great, but obviously they can get to the repository, and we're close on time. So let's go ahead and show the good stuff.
Okay. Yeah. So we'll exit presentation mode, and then we will go over to Chrome. And all I need to do. No, not yet.
Okay.
Oh yeah, I've got to run that. Yeah, that could be kind of important.
Ahead, yeah.
Way too much excitement. That's what it is. Thank you. Oh, I got to run my database too.
Oh, whoops.
I got to spin that up.
That's
second.
going to give us a really nice little,
Yeah,
it's going to bark at us, but that's all right.
Oh.
We can fix it. It didn't. Must be.
It's not hitting the database yet.
There we go.
Where is it? Is it here? No, it's Marvel. Spin up. So I loaded everything into a local database. Come on. With IntelliJ and video and everything else. Yeah, it's like, Okay, go back to here. So now if I do the localhost 7474, that's Neo4j's normal connection, and then it's just graph. What?
7474 is you're actually hitting the admin panel.
Oh, yeah, you're right. Hang on.
I figured maybe you want to.
It's 8080, right?
Yep.
Huh, my normal. You can see I'm on autopilot there.
My fingers are going.
And then just graph.
This is where
There it is. Yeah. So this is our visualization at this point.
Oh, scroll.
There's our graph. Yeah, and you can drag this around.
And this is still very much a work in progress. I mean, we wanted to get a proof of concept up quickly, but this gets us an idea that obviously the many relationships among the various nodes. So if you want to click on any of the different issues, of course, it'll load the different issue. You can see what characters are in those issues.
And it re-renders the graph for you each time you click.
And click the secret Avengers, if you would. And that way we get some various different characters up here. Oh, just a couple. Yeah. So if you search on, let's say, search on Iron Man.
Yeah, I set it to Captain America because he's my favorite. So that's just my automatic go-to. But you can search anything in the database. Again, you can click and populate different information. You can see, as we mentioned before, that the Marvel API kind of has some missing things. You can see there's an untitled story here. There's a missing image here. We could kind of improve and show some better kind of, not really error messages, but kind of getting around those errors a little bit.
Right. Their data cleansing could use some love, but we didn't feel like it was really. I mean, obviously, in your various different use cases, that may be very important to clean that up and shield your users from some of that. In our case, we just figured, well, if the Marvel Data API or the data doesn't have that particular bit of information, we'll just show they don't have that bit of information. So let's click on one of these, which, wow, you know, the page it's great, but the characters there aren't that many characters in that particular one. So, but it gives you an idea of what is capable from one, a fairly decent trove of data, a public data API, Neo4j and the various different libraries, APOC, the various different ways you can structure some pretty crazy impressive queries, and Spring Data and Spring Boot to make it immediately very productive to get an application up, running, and out and deployable very quickly and easily as a developer.
Yeah. So I'll switch over to our presentation here.
Question for you, Jennifer, about how you're storing the images. Maybe you can explain a bit how you've done that.
Yeah, so basically all it is in the Marvel API, they give a URL. And so all I'm doing is basically sourcing that URL in and storing it in the Neo4j database. And then all I ended up having to do was in the HTML file, I had to wrap it in an image tag. And it reads that URL and brings that image in for me.
So it's a library, not actually persisting the graphic itself.
Correct.
Yeah, cool. And then, yeah, I guess the other thing interesting maybe, how many hours or how many days do you reckon it took you to build what you've just done?
Okay. Well, the import, because I have the Cypher statements out there in that import script. It's in the repository link, which you should see there in the middle, the source code link. So the import script should be out there. I just ran each of those queries in a Neo4j browser and then loaded that data in. So I would think maybe.
You're answering the how long would it take to reproduce this, but
oh yeah.
But to come back to the original question, it took you a long time to because the data and the API and the rate limiting was just kind of a. I mean, all the pieces are there, but it was a lot of manual creation and assembly. So she took a ton of time getting the data import right and fairly clean and usable. And then the front end part of it took a significant amount of time. We borrowed some code from a couple other projects, and then it still took us quite a bit of time to tune that and get it the way we wanted to present in the front end.
To be honest, the Spring application in the middle was probably the shortest. It was so easy.
So that, and that's the good side of that. The bad side is there really wasn't as much for me to do. So I'm cheerleading more of the time, 80% of the time. But yeah, it took significant amount of time on the back end. Data and on the front end presentation. So I don't know, several days on each, I think. Maybe a few weeks. Really, by the time it's said and done.
Yeah, for me to start from scratch, to reproduce, I think probably a few hours. Yeah, you could have this up and running.
We tried to put all the pieces out there to where it would be very simple for someone to just get clone and be off and running pretty rapidly.
Yeah, and of course you could just go straight to the Marvel API. You could just hit the Marvel API and call that without having to store that data into the database. It was just, first of all, you never know what conference Wi-Fi is going to be like, or hotel Wi-Fi or anything like that. So we didn't necessarily want to rely on their servers and their service. And then also we wanted to have a local Neo4j instance just to be able to do our own, maybe if we wanted to clean up the data, and just kind of have more manageability around that.
Well, it gives you a lot better relationships too, because if you're trying to pull in various different API calls and wire that on the fly, that's not a fun task.
Any other questions?
No, that was all I've got for the moment.
Okay. Well, we do have some resources out here, Spring Data Neo4j docs, as well as Neo4j and Spring basic information and documentation. Of course, we did assume some basic level of understanding for Neo4j and building applications and such. So if you guys have any just kind of introductory questions or overview high-level questions that we didn't really cover in this, feel free to reach out to us. We're more than happy to kind of step through or explain some things additionally as well. Our source code is there. You're more than welcome to go out and replicate. We do have a couple of branches on that as well that give you just kind of basic framework of the project, and then you can fill in the details and fill in the methods and such at your leisure. And of course, feel free to reach out to us, Twitter or email or however else you feel appropriate to get a hold of us.
Yep, always open. Just ping. Any questions? The only bad question is one not asked. So we're happy to go into any level of detail on any of it. Just happy to help.
Cool. I guess we can hand back to Karine again then.
Okay.
Hello. Thank you guys so much for that. That was amazing. Very well done. Mark, do we have any more questions on the chat that you think that would be interesting to ask or comments? The video is generally a little bit delayed, Jennifer and Mark, so sometimes it takes a minute for people to ask questions and then to populate on the stream. So
no, I think we've covered the questions that we've had so far. Okay. By the way, I realized my room is now completely dark. I guess that people probably need some time to check through the code, and then we've got the link to the community page. You created a page on there, so if you scroll to the top of the chat, if you're watching this later on, if you have a specific question, you can ask it on there, and we'll put the links that you shared on the last slide maybe on that page as well.
Great. Thank you so much. I think that about wraps it up.
Cool. Yeah, and I guess if you enjoyed the talk, don't forget to like it so that other people can
Yeah, give it a thumbs up.
Yeah, we're like YouTube gurus. Cool. Thanks, everybody.
All right. Bye.
Bye.